Hi guys, today we'll be going through stationary points, which is section 12.9 of the AS level Pearson Edexcel textbook. Now, a stationary point is a point on a graph where the gradient is 0. Or in other words, where f prime of x, so the derivative, is equal to 0. Now, there are three types of stationary points. A local maximum, where the gradient is initially positive and then becomes negative. A local minimum, where the gradient is originally negative and then becomes positive, or a point of inflection, where the gradient is can be either positive and positive on both sides, or negative and then negative on both sides. Now, you can identify whether a point is a maximum, a minimum, or a point of inflection by using the second derivative. So if the second derivative is equal to 0, then the point is a point of inflection. So when f prime prime of x is equal to 0, then you have a point of inflection. When f prime prime of x is less than 0, then you have a local maximum. When f prime prime of x is larger than 0, then that point is a local minimum. So, if we were asked to sketch the graph of x squared at 6x at 8, the first thing you would do would be find where the turning points are. So f prime of x. So first you differentiate f prime of x is equal to 2x at 6. And to find the turning point, you know that the derivative must be equal to 0. Therefore, 2x plus 6 must be equal to 0. Therefore, 2x must be equal to negative 6. Therefore, x would be equal to negative 3. And this is your turning point. And you know that when x is equal to negative 3, f of x must be equal to, so f of x must be equal to negative 3 squared, add 6 times negative 3, add 8, which is just 9, take away 18, add 8, which simplifies down to negative 1. Therefore, your turning point is negative 3, negative 1. Now, to determine the nature of the stationary point, so whether it's a local maximum, local minimum, or point of inflection, you would need to find out the second derivative. So let's do that here. So f prime prime of x would be 2, because you just differentiate this again. And because f prime prime of x, or the second derivative of the original equation, is 2, 2 is larger than 0. Therefore, this turning point or stationary point must be a local minimum. To sketch the graph, we also need our roots. And to find our roots, all we do is factorize the original expression. So we know that f of x is just equal to x plus 4 multiplied by x plus 2. Therefore, our roots are when x is equal to minus 4 and x is equal to minus 2. Now, have a go at sketching this graph. Now let's sketch the graph. So, first you draw on your axis, and the roots are minus 2, minus 4. And we know that our turning point is minus 3, minus 1. Therefore, our turning point's down here. And because it's a local minimum, the graph is going to look like this. So an upside down U. Sorry, not an upside down U, a U or an upside down A. So let's draw the graph. And we know that our y-intercept must be 8 because 8 is the constant at the end. If we can label this 8. And this is your graph. This is also a very common exam question, so make sure you're able to do this before your exam. Now guys, thank you for watching. Please like, subscribe, and if there's anything you want me to go through, any specific topic or any specific question, please just leave it in the comment section and I'll go through it for you. Thanks for watching, and as always, good luck.